Hello and welcome back to the Unity DOTS series. In a group of lessons here, we're going to take a look at some different topics about learning the fundamentals of DOTS. And today we're going to look at using systems. We'll look at practical examples more than theory, but I'll give an introduction to the Unity DOTS package, as well as the RMC Dots package built on top of that includes the examples. So everything that you see in the video today here, you'll be able to get at and play at inside Unity yourself. So hello, my name's Sam. I'm a Unity game developer with over a decade of experience with over 20 years in total doing game dev with various technologies. I'm relatively new to DOTS, having played with it along the way before 1.0, and in the last year since 1.0, giving it much more time. My professional experience includes teaching and creating games around Unity technology as well, shipping titles for mobile, PlayStation, Xbox, Steam, things like that. Also teaching those fundamentals. I have given different videos and different talks and different courses on general Unity game dev experiences, as well as doing SDK-based product overviews, reviews, how-tos, tutorials for multiplayer Web3, things like that. Deep into Web3 over the last couple of years, and now getting into DOTS as an alternative way to do development inside Unity. So a quick overview about DOTS. If you do want to learn more, check out the link above and also in the bio below for a video that covers more of the basics. But Unity DOTS is data-oriented technology stack. It's a combination of three key technologies: Unity Jobs, Unity Burst, and Unity ECS. So if you want to see more about the basics of that, check out the links, and we'll move forward here and talking about why do we want to use DOTS. Well, one of the key reasons is performance. So a great example of this, you can find many, but Door 407, which is a game dev company that I found as doing my research here, they had a fantastic demo on one of the forums. So let's take a look at that demo now. It uses Unity DOTS. I'm not exactly sure which version, and just shows highly efficient runtime experience. So here's the demo. I have it running full screen on my computer. Now, if we were getting into the details, I'd tell you about system specs. I'd tell you exactly how many entities we've got moving on here, but let's just dig in and enjoy it for a moment. So lots of things on the screen, and I'm going to use mouse and keyboard to drive around in this world. We're running at a frame rate of 100 to 150 or so. I'm able to move down here and see that what appears to be little dots are actually animated characters. It's the same one character, but each of them running their own logic and their own animation, and we see we have a ton and a ton. All of them running independently. We got really well over 50 frames a second here. This is just a proof of concept, but you can see just how many different objects we've got here. Let's spin around here again. And this is without any particular optimizations. We can turn on this culling and be able to crank it up and down. And what this does is a certain distance away from the camera, the characters are not animated. They're still being rendered, which would be a great optimization to do. But even if I turn off the culling here, on my pretty beefy game computer, we've got lots and lots of objects running. Now, this type of thing would be possible without DOTS inside Unity, but we would not be able to render nearly as many objects running this logic, animating as we do here. So it's a great, simple example at the scale that you can get when you embrace Unity DOTS. Again, that great demo was created by Door 407. And now a brief introduction to the RMC Dots Library. So this is something that I created custom. It's available on Git. If you want to learn more about what it is and what's inside of it, you can take a look at the link above and the link again in the description below. The RMC Dots Library provides new features and demos built on top of Unity DOTS. DOTS, again, is Jobs, Burst, and ECS, as well as some other supporting libraries. And inside the RMC Dots library, you have the library itself, which has some helpful features, and then samples built on top of it. We're going to take a look at one of the samples today, which talks about different lessons, learning your way along with DOTS. So how do we get the samples? Well, they're all sitting on Git, links below, and there's two different flavors of it. You can get the RMC Dots package and bring it into your existing Unity project. That's great for production use case, and it has the examples you can pull in as well. Or what I call the RMC Dots examples repo has that plus a Unity project, and that's what we're going to jump into. Now, the benefit of choosing the RMC Dots examples repo is that because it includes that Unity project, everything's set up. You open it up, and it just works. You don't have to install any of the packages or dependencies that are needed for Dots or my flavor of Dots. Then you just open up the Unity Hub, point to the Unity folder, and voila, you're now working in a fairly empty assets package, as we'll see here. And then you can optionally bring in some of the RMC Dots samples, which we're going to look at the lesson sample today. So let's see this in action. And as we're going through looking at these samples or any of the samples that I'll go through in the video series, I want to step through my approach as I'm learning and using Dots. First, I prototype a feature. In the case of my learning game development with Dots, I created a Pong game and a 3D game, and I'll continue to create a few others for learning's sake. And I created them with game objects in OOP first. Then, after seeing how that would play out in the traditional areas of my strengths with using OOP, for example, then I try to translate those in a prototype of Dots. So in the prototype phase of using Dots, you're looking from a user's perspective. In a way, for a moment, you don't care about how you created it. You just want to replicate the right end user experience. So in the case of a Pong game, having the paddles move around, having the ball be able to bounce, having the scores reward, having the audio play, you just want to get that done in a quick and dirty way, not worrying about it being perfect, using Dots. Here you're looking at translating your learnings from OOP into the Dots world, and you're focusing on the functionality here. Then once you get that done, which over my learnings, I've gotten pretty good at the prototyping phase, being able to imagine how a feature I would have done with OOP is now possible using Dots. Then I shift my mentality to a production mindset. I think more from a developer's perspective. I try to connect that one feature to the rest of an architecture. For example, thinking about not only how would the Pong ball hit the goal, but the result, how would it plug into a sound effect system? How would it reward score to the UI? How would it reset the game flow? And you're starting to think more in interoperability. How does that one system connect to the rest? And that is another area of great learning, just to get it not just functional, but actually playing nice with the rest of your game or your sample demo project. That's pretty much where I'm living right now, is in this production area. Then I would say the next step, which I'm definitely not an expert in, is polishing. The polishing phase here is looking at things from a computational perspective, from the CPU and from the GPU, studying the optimizations and the frame rates that you can get out of a system. Also understanding at a more complex and complete level, how does Dots connect with your hardware, and how does designing your systems in the best way to get the best performance. Here you're refining the efficiency of the feature. You're sitting more in the profiler, looking at the RAM consumption, the CPU consumption, the GPU consumption. And as you're looking at the demos in this video and others in my series, if you have an alternative approach to recommend for a different way to prototype something, for a different way in the production mindset to connect it to the rest of the systems, or most importantly for my learning, a different way to polish it, a different way to get a more efficient result, do leave me a comment in the video. Do leave me a comment in the Unity forums where I post these videos. And also feel free to do a pull request on the RMC Dots library itself and submit a different way to do it. I would love to learn from the audience here and see better ways to do each of these. So now let's jump into Unity. Here I've gone to Git, I've gotten the RMC Dots examples repo, and I'm opening up fresh. So let's do a quick check of the package manager just to see what we've got involved. So I'll make this nice and big for us. So here we've got the RMC Dots package. We've got, because we've chose the RMC Dots examples repo, it has all of the different Unity dependencies that we need. Most importantly, entities, but there's lots of other ones that are in there for as well. And for RMC Dots, we can go over to the samples here and we can choose the lessons. Now, before I click on the lessons, I just want to show that here in the packages, that the RMC Dots library sits down here in packages. So if you're familiar with how Unity organizes their packages, it works just like that. Anything you pull from the package manager sits down there. And that is generally not editable content. We just use those libraries. Then inside of our assets folder is where we build our actual game. And here we have read and write access. Now, I don't really need to have anything inside here, but what I chose to do is to include the URP rendering, just so that all these examples play really nice. But if you want to replace that, no problem. But that's already wired up and ready to go. You just hit play and the scene works. And then I have this README that includes some instructions about how to bring in these samples. So I know how to do it. So I just go to the samples. I go to RMC Dots right here. And there's the RMC Dots lessons, library demos, game samples, and game templates. We'll be bringing in the RMC Dots lessons. So I'm going to click import there. Unity is going to recompile, and it's going to add some things from the packages up into the assets, and now we can work with them. Along the ride of using dots, you'll see all sorts of little errors that pop up. General best practices for Unity always to take care of these errors, but you will notice that sometimes an error pops up like this one, and you click clear. If when you click clear, it goes away, it's just a temporary one. The burst compiler, for example, is always complaining and giving you some very temporary ones. Once it recompiles, it has no issues. Now, if we look at the samples, we expand those out, we see the examples that come. So we've got an example about spinning a cube and other examples. And you might see that when you bring into this project into your Unity, you've got different folders here with even more content added. The one we're going to look at today is spinning a cube. So we've got the same exact example done several different ways. And let's take a look at each of them in turn. First, let's look at a scene where we're spinning a cube with a game object and with a mono behavior. So this does not yet use dots. And let's take a look at how that's done. So we've got our scene set up here. In all these scenes, there's some common elements like the game camera and the directional light that just help us get this scene going. Then we've got one script named after the scene, and that's just going to give us a little bit of orientation. And then we've got the spinning cube itself. So let's take a look at each of those. First, I'm going to hit play and just see how the scene works here. So the scene here gives us a little info. Just watch the spinning cube. In some of these examples, it might mention use the arrow keys to play with the demo. This is just passive. You just sit here and watch it. Now, for those familiar with Unity, you know that when I click on the spinning cube and I see our spinning cube script here on the right, we can see that the different values of different components are changing at runtime. So the rotation, for example, here is changing as we also see it changing in the game view. And down here is the spinning cube custom script that I created that does the spinning. And for that, I pass in a reference to the cube itself. And I also do the rotations here with a speed in the X, Y, and Z. Now, if I was to tweak the Y like this, you can see it rotates even faster in that given axis. So standard Unity stuff. And just for a comparison's sake, before we step into dots, let's take a look. This is the one script that makes this work. So we've got our using Unity engine in our namespace, jump down here into the class. Class extends mono behavior as we do in traditional game object-based OOP approach to Unity. This style of programming has been around since Unity 1.0 over 10 years ago. Now we serialize a couple fields, which makes them available in that inspector. And then here, the real meat of the entire experience is we take advantage of an existing update loop. Unity calls this for us automatically, and anything we put inside gets called once per frame. And here we use the cube transform rotate, which is built-in functionality. That's it. Now, this is meant to be a review for anyone experienced in Unity. Now let's step in and see how we do that exact same thing inside Dots. So let's take a look at a second example here. We've got a few different ones because there's a few different flavors of how to set this up. First, let's take a look at the scene structure itself. There's something a little bit unique. So know that when we're developing with dots, what we're doing here is we're merging the traditional game object-based system with the new dot system. It is always the case that there is some mixture of the two. The more you know about dots and the more systems that you use that are based in dots, there will be less of that game object interface there, but it's always there. For example, here in the scene, we start out, we have a spinning cube here, which has a mono behavior just used to give us a message in the console. That's pretty basic. Then down here, we have a pretty new concept. If you've never seen dots before, this is called a subscene. And whenever you're in a regular old Unity scene and you want to create a subscene, you right click, you go to new subscene, and you give it a scene name. What that does in your project window is it creates a subscene, which the icon and the naming and stuff like that looks pretty similar, but it has a distinction here. It lives inside of another scene. So here we have the version 2 dots scene, and inside what looks like a game object here is actually a reference to the subscene. Now, why do we have subscenes? They exist for, as far as I know, exactly one reason. Everything in the subscene is the dots world, and everything that's not in the subscene is the traditional game object world. So this is a game object, this is a game object, this is a game object, and everything inside here is going to be the dots world. And there is a bit of a life cycle here to understand that at this point, when I look at the scene, it looks pretty traditional game object here, right? There's a workflow where as I click the play button, this will get converted or baked into dots. Now, why did they bother to do that? Well, we have a lot of wonderful tooling here inside the Unity editor, which is built on game objects. We're very familiar with the workflow of exposing serialized fields out here using mono behaviors. So we get to take advantage of all that. What we're looking at here, the spinning cube component authoring script, is a mono behavior that I created, and it allows you all the nice conveniences of serialized fields and custom editors and all that kinds of stuff. What happens when I click play, it happens in a few different times in the life cycle, but for simplicity's sake, what happens when I click play is that this gets converted or baked into dots. So let's see how that works. I click play. Now the end result scene here looks the same. We've got a cube and it's spinning around. It is purposely very simple, and we'll look at the code and see how it is different than the mono behavior before. Something to note here is that because we've brought in the Unity entities package, we've got this extra drop down here that you typically wouldn't see in Unity, and it allows us to see the inspector in different modes. If I put it on runtime, it will now show us the inspector for the spinning cube, but with the dots related component datas. So it kind of looks similar. They've got some different icons and stuff, but section by section, each of these represent not a mono behavior component, but a dots component. And that distinction is important. So the workflow that we've seen here is we start with a traditional scene, we create a new subscene. Anything that we drag into that, a regular old game object, will be converted at runtime, actually at bake time before the run. Now, what gets converted? Well, only game objects that are configured for conversion get converted. So a lot of the built-in Unity stuff, for example, the mesh render to render this cube, gets converted. But what about custom scripts? Well, let's take a look at that. So in order to see how all of this works together, let me look at the scripts. And here's the three we're going to look at. So we've got the spinning cube component, the spinning cube component authoring, and then the spinning cube system. Now, when we've talked before in the previous video and covering the series and how the theory of dots works, I mentioned the ECS system within Unity. So when you bring in the entity component system, that it's a paradigm about dividing your logic up into those three buckets. The component portion is here. The system portion is here, and the entity refers to the game object, so to speak, the thing itself that we're speaking about. So here we've got a spinning cube entity that has a spinning cube component, and it's being manipulated by a spinning cube system. So those are the three core parts. Now, if that's true, then what's the authoring? The authoring is the script that converts the mono behavior into dots. So when I have my own custom component, like the spinning cube. Unity doesn't provide that for me, so I also create the authoring. Let's take a look at all three of them in turn. Well, first, imagine that we wanted to spin a cube around. What types of data would we want to store there? Well, a very popular one that I used in my last example with OOP is just the speed at which it should rotate. So not the rotation behavior itself, but just the speed. So let's take a look at our spinning cube component. So here's the code for a spinning cube component. I implement the interface of iComponentData. There's nothing really that comes along that I need to do there. I wouldn't necessarily have to have any data inside of it. I could have it like that. But as my original example has here, I have a vector 3 representing the rotation. So how much is it going to rotate in the X, the Y, and the Z? Notice that it is not a class, but a struct. So it's a bit of theory for us to learn together, the difference between classes and struct. But you'll see that there's a very purposeful use of structs. It's in a more efficient approach for some of the data types like the component data. Now that we've got that declared, we have to think about, well, how do we convert it from that nice, friendly mono behavior inspector that we saw at edit time to be able to tweak those values and bake it? That's what we use the authoring for. So right next to the component we just looked at, here's the component authoring. Let's go ahead and run that. So here we see a mono behavior, which is the traditional Unity approach. Anything that we create a mono behavior, we're able to drag it onto a game object. And here it's going to convert something from the mono behavior world into the dots world. And the conversion happens down here in this entity portion. So first thing we do, if you imagine we were creating our own from scratch, we would create a spinning cube component authoring. That's the naming convention I like. You could name it what you want. You extend mono behavior, and you want to declare something here to put into the Unity inspector. Notice that it's very familiar to our spinning cube component, but this one here is a struct implementing iComponentData, and this one here is a class extending mono behavior. The point of having them be similar public vector 3s is you're going to convert from this one to the other one. And the way you do conversion here is by creating a new baker class. So you create a custom baker, you pass in the type of the authoring itself, so that matches up, and then you override bake. And this bake happens at some key moments along the way, including when you're running the scene. This does the conversion for you. So first thing we do is we're going to create a fresh entity. So we'll create get entity there and store that. And then we add our spinning cube component on top of it, and we pass along any data we want. Notice here that when we're doing the conversion, we're going to say that the dots rotation delta should equal the game object rotation delta. So that's where we're passing it. Now, once this bake happens, we no longer need the game object per se. We don't use it in the rest of the world. Now, sometimes in DOTS projects, you might still need that reference to the original game object because there's still some systems that don't yet fully use DOTS. But for the most part, you can think after baking, the game object has now disappeared and we're now in a DOTS only version of the project. So let's run the scene again, and then we'll look at the system. So I haven't purposely changed any of the code here. I think just by commenting and uncommenting a few things there. Now we're running here, and again, the spinning cube here, we have the concept of the game object version, which we saw in the mono behavior. Then I can toggle over to the runtime experience here and see the dots version. Now, there's lots of components that we didn't see me add. Let's find the one that I did add first. There's lots. Let's see here. Here it is. So the one that I added was the spinning cube component, but Unity automatically studies the other aspects of that game object, and it adds all the dots equivalents that it needs. So transform becomes transform, local transform. There's different things for physics. If you have physics applied to the game object, which I did, I had a collider there, different render bounds objects. So all of this stuff, it does automatically. The one that I did was the spinning cube component. We can see that gets added here. And I am still able to tweak it and be able to manipulate it here, just like you'd expect in the inspector, and get that immediate feedback. So lastly, let's look at the system here that we use to actually do the translation. So the third piece of the puzzle here is the spinning cube system. When you're creating your own system, you have two major choices you can make. You can create a struct, as we do here, and implement the interface ISystem. You'll find literature in Unity Docs and other popular videos discussing this, that one option is ISystem and another one is SystemBase. The general difference here is that ISystem is lower level, faster, but has some limitations. And SystemBase is a bit higher level, a bit easier to use, and has less of those limitations. If you can do it with ISystem, it will run faster. Now, there's going to be some exceptions to that rule, but that's a good way to think about it. Then along your way, you might realize, well, I actually need it to be doing something and ISystem can't support it. So then you switch over to SystemBase. The general setup is pretty similar. You're going to be doing an onCreate, which happens once when you click play and the system is created. And then you're going to do the onUpdate, which happens every single frame along the way while the system is running. So let's look at each of these parts. First, well, on the onCreate, you have to tell this system, well, what are the different components that I plan to use in the onUpdate below? If I don't declare these here, depending on what exactly how you're approaching your system creation, the compiler might yell at you and say, hey, in your onUpdate, you can't grab a reference to this or that unless you tell us in the onCreate. So why is there that extra step? Well, when you're working with dots, you'll see quite a bit of that you need to be very purposeful and clear, telling the systems that you're building on top of, telling the ECS in this case, hey, I plan to use this, so get ready to optimize the system so that you know you won't be surprised at runtime about what I'm doing. So that's why you declare these things. So I'm saying update will only happen if anywhere in my game there's at least one local transform, which is the equivalent of the game object transform. I'm going to be using that to do the rotation. And then also only run an update if there's the spinning cube component. That's the custom component I created. So if you think about spinning a cube around in the dots world, there's two things that I need. I need to actually get a reference to the thing to spin. That's the transform part, which is local transform. And then I need to know the speed at which I want to transform it by. And that's my custom component. So those are the two pieces that I need. Then down here on the onUpdate, this is going to get called once per frame. And I'm going to loop through and perform the translation. Now we see in my simple demo that I only have one cube spinning, but something to wrap your mind around when you're thinking about ECS and this dots approach is that while there are exceptions, I'm going to use the following example just for simplicity's sake. You always treat everything in your game like there's a list of many, many possibilities, right? So while I only have one cube, we pretend there's more than one, and you always loop through a list and say, tell me about all the cubes in the scene where something needs to happen on them. Now, and we know because we've seen my scene, there's exactly one, but you're still doing a for each, right? If I duplicate my scene and I have more than one, then it will still run great. You're always designing things in this list-based approach or this for each based approach. Now, the syntax here for the for each looks a little bit odd, but essentially what you're doing is you're saying, hey, system API, do a query, look into my scene, and tell me any one entity out there, in the case of each loop through the query, give me one entity that has all of the following, that has a local transform and that has a spinning cube. Now we know in my simple scene, I've got one thing out there, the cube, and it happens to have both of them. But you can imagine a game that has a spinning cube and a static cube and an enemy cube and a player cube, and maybe all of those have the local transform, but not all of them have the spinning cube component on them. Another one might have the translate component moving up and down. It might have the scale me component, it might have other ones. But this one tells us, it returns us all of the different entities that have all of these following things. And then inside, I'm able to operate on that. So let's say here in shorthand, this finds the one cube And then down here, it rotates the 1 cube. And how does it do that? I'll move this up a little bit for us. So here in this section, we're going to rotate that 1 cube by first getting the rotation from the local transform. Then I do a math operation on it, which is custom in this particular case, to get the next rotation I want to run at. I'm using delta time, which is a traditional Unity approach to animate smoothly. You multiply by delta time, and we do that same thing here. And then in the third line there, I set the local transform rotation to the current rotation times some additional rotation. And that's it. Now, depending on what axis you're rotating around, and if you want to rotate to a specific angle or rotate by a specific angle, these 3 lines might change a little bit. But know that inside the for each, you're able to access values from these components, which we've queried, and you're able to set back values on there. And depending how you construct your query, you're actually declaring this component I want to read from, this component I want to write from. But for the sake of simplicity here, let's just say you construct your query and you can access what's in the query, and then you do the changes. So that's it. We've taken a look at completely the component itself for the spinning cube, the authoring component, which translates from the game world over into the game object world, over into the dots world, and then seeing how our system works here. I'll run it one more time. So here it's running as we'd expect it to. Again, we looked at the component, we looked at the component authoring, and we looked at the spinning cube system. Now, for the purposes of this video, that's all we're going to look at. We looked at the game object approach. We looked at one of the dots approaches. Well, what's the version 3, 4, 5? I might add more in the future. Each of them cover a particular approach for these various versions of spinning a cube. We looked at the one that has mono behavior using mono behavior update. And we looked at number 2, which uses ISystem and that for each approach to do the query, and that has burst. Now, burst, anytime we're using burst, it's going to be able to run that much faster. So that's a great advantage. Already we see in dots, we're able to use burst. If you want, get this project and step through the other examples. You're going to see ISystem with iJob entity, with different queries as well. And then finally, there's an example of SystemBase using no burst. So you can see that there's different flavors, and there's a reason why you want to maybe use one of those over another given a specific case. In this situation, I would say the approach in number 2 is one of the best ones available because it is an ISystem, which is lower level and theoretically runs faster, and it also has burst enabled. So that's wrapping it up here for taking a look at this particular demo. We've looked at lessons and how to get the lessons project and get that out of our RMC Dots library. We've taken a look at an example of doing a spinning cube with a game object approach, doing a very basic version with dots, and then hinting at there's some alternative approaches that you could look at in the kind of how do we optimize this system better. So dig into the code in the source, again, link below to everything that we talked about today. And if you do know a better way or another version that we could do this with the spinning cube, do leave me a comment below in the video. And also feel free to do a pull request on Git and tell me more about a better way to do one thing or the other thing. Thanks very much. I am available for remote contract hire as a Unity game dev, doing traditional game object approach, as well as Unity DOTS development. And also I'm an educator available to create and deliver courses in person and online, pre-made courses or live. And I would love to do more talking about VR, AR, dots, Web3, and game development with Unity in general. So thanks very much.